Hey everyone, and welcome back to What's Going On in the Internet.
Glad to be here.
I'm Peter Dawell.
And I'm Nora Kane.
Our network whiz. Ready to break down some internet mysteries today, Nora?
Always up for a challenge, Peter, especially when we can help those informatics students out there.
That's the spirit. And speaking of challenges, today we're tackling a topic that might seem a bit, intimidating at first.
Yeah.
Implementing Ethernet LANs.
Oh, yeah, that one can be tricky for sure.
But it's absolutely crucial, right? I mean, it's the foundation of how our devices connect.
The backbone of modern networking. We'd be back in the dark ages of sneakernet, I guess.
Sneakernet, huh? Remember those days? Walking around with floppy disks?
Ugh, not really. I'm too young for that, thankfully.
Right. Anyway, imagine plugging in your device, expecting that instant internet gratification, and nothing. We've all been there.
It can be frustrating for sure, especially when you don't know what's going on behind the scenes.
That's exactly why we're doing this deep dive today. For all you informatics students out there, maybe even sweating over that upcoming CCNA exam, this one's for you.
Consider this your Ethernet LAN survival guide.
We're going deep, using chapters 4 and 5 of your CCNA study guide as our roadmap. Think of this as a behind-the-scenes tour of how those connections really work.
We'll explain the why, not just the what.
Perfect. So, let's imagine you're in the lab, you've got your shiny new Cisco switch, the heart of your Ethernet LAN.
Okay, I can picture it. What's next?
How do you even start talking to this thing?
That's where the magic of the command line interface comes in, or CLI for short. It's like a direct line of communication to the switch.
It's a CLI, right? Those cryptic commands that make the switch do our bidding.
Exactly. It's all text-based, no fancy graphical interfaces here. You're typing in commands, sending instructions to the switch, and it responds accordingly.
And the CLI is like the bread and butter of the CCNA exam, right?
Yeah.
I bet there are tons of questions about specific commands and how to use them.
You bet. Cisco really emphasizes CLI mastery, and for good reason. It's the foundation of network management. Understanding the CLI gives you the power to, really control your network.
So no clicking around with the mouse, just good old-fashioned typing. It's like back to the roots of computing, right?
In a way, yeah. But don't let that intimidate you. The CLI is actually pretty logical once you get the hang of it, and it's incredibly powerful.
Okay, so we're ready to channel our inner command line ninjas, but first, we need to actually access this CLI. How do we do that?
You have a few options. There's the console connection, Telnet, and SSH.
Okay, let's break those down one by one. What's the console connection all about?
It's like the most direct route to the switch. You're physically connected with a special cable, usually called a console cable.
So I'm literally plugged into the switch with a cable. What does this cable look like?
It's got an RJ45 connector on one end, like your standard Ethernet cable, and a serial connector on the other end. That one plugs into the switch's console port.
Got it. So I connect the cable, fire up my computer, and boom, I'm in the CLI.
Not quite. You'll also need a terminal emulator program on your computer. This software allows your computer to talk to the switch over that console connection. There are a bunch of options out there, like PuTTY, Tereva.
The terminal emulator. I remember those from my networking classes. They're like those old school green screen terminals from the movies, right?
Exactly. And you usually have to set a few things in the terminal emulator, like the baud rate, which is how fast the data is sent, data bits, parity, stop bits, all that good stuff.
Okay, now you're bringing back some memories. Baud rate, data bits. It's all coming back to me now. They're like the rules of communication, right? Making sure the computer and the switch are speaking the same language.
You got it. It's all about making sure the data is transmitted correctly. And for Cisco devices, the standard settings are usually 9600 baud, 8 data bits, no parity, 1 stop bit.
Got it. So console connection, check.
Yeah.
Now, you mentioned Telnet and SSH as other ways to access the CLI. What's the difference between those and the console connection?
Well, Telnet and SSH let you manage the switch remotely. No need to be physically plugged in.
That's convenient, but I also remember hearing that Telnet isn't very secure. Something about sending your commands in plain text.
Yeah, that's the problem with Telnet. It sends everything in plain text, including your username and password. Not very secure at all.
So anyone snooping around on the network could potentially see my credentials. Yikes.
Exactly. That's why, in the real world, SSH is the way to go.
Okay, so SSH is the secure option. What makes it so much safer than Telnet?
SSH encrypts all the communication between your computer and the switch. It's like sending secret messages that only the switch can decode.
Ah, so it's like sending a sealed letter with SSH, while Telnet is like shouting your secrets across a crowded room.
That's a great way to put it.
Okay, so we've got our access methods sorted out. But before we dive into the CLI, there's one crucial thing to remember about default settings.
Yes. Default settings, always a good reminder, and a potential security pitfall.
Yeah, default settings. It's all about security again, right?
You bet. When you get a new Cisco switch, it comes with these default settings, including a default username and password. And often, these defaults are really simple, sometimes even publicly known. It's like leaving a key under the mat for anyone to walk in.
So the first thing we should do is change those default passwords to something strong and unique.
Absolutely. It's like locking your front door. Never underestimate the importance of good passwords.
Okay, security first. Always.
Yeah.
So we've got our access sorted out. We've secured our switch by changing those default passwords. We're staring at the command prompt, ready to unleash our inter-network wizards. What happens next? How do we even begin to navigate this CLI world?
Well, the first thing to understand is that the Cisco iOS CLI is organized in a very structured way. It has different modes, and each mode gives you different levels of access and control.
Modes. Sounds intriguing. Are we about to unlock some secret levels here?
You could say that it's like a video game, sort of. Each mode has its own set of commands and its own purpose.
So what are these different modes, and how do we even know which mode we're in?
The two basic modes are User EXEC mode and Privileged EXEC mode. User EXEC mode is like the entry-level mode. You can look around, but you can't really change anything. Privileged EXEC mode is where the real power is. That's where you can configure and manage the switch.
So user EXEC mode is for window shopping, and privileged EXEC mode is for actually buying stuff.
Exactly. And the prompt, that little symbol at the beginning of the line, tells you which mode you're in. In user EXEC mode, you'll see a greater than symbol. In privileged EXEC mode, you'll see a #, hashtag.
Got it. So if I see that I know I need to level up to privileged EXEC mode to make any changes, how do we do that?
You use the enable command. It's like the magic word to unlock those admin privileges.
Enable? Okay, I'll remember that. But I'm guessing there's usually a password involved, right? We weren't just anyone strolling into privileged EXEC mode.
You're right. Usually you'll need to enter an enable password to get into privileged EXEC mode. Security first. Always.
Absolutely. Layers upon layers of security, like a delicious parfait. Okay, so I'm in privileged EXEC mode, ready to start configuring this switch. What's my first move?
Your first step is to enter global configuration mode. This is like the command center for the entire switch. From here, you can make changes that affect the whole system. Things like setting the host name, configuring system-wide settings. You can even create VLANs from here.
VLANs. We'll get to those later.
Yeah.
So global configuration mode is like the control panel for the whole switch. How do I get there?
You use the configure terminal command. Think of it as opening up that main control panel.
Configure terminal. Got it. Now, what if I want to configure specific parts of the switch, like individual interfaces or lines?
That's where those more specific configuration modes come in. From global configuration mode, you can navigate to different sub-configuration modes, each one dedicated to a specific part of the switch.
So it's like going from the main control panel to a specific settings page for, say, the network interfaces.
Exactly. And to get to those specific pages, you use those context-sensitive commands we were talking about earlier. For example, to configure the console line, you'd use the command line console 0. That puts you into line configuration mode where you can set things like the console password.
So it's all about navigating this hierarchy of modes, using specific commands to get to the right place. And each mode has its own set of commands that are relevant to that specific area. It's like a choose-your-own-adventure for network configuration.
I like that analogy. And don't worry, the prompt changes as you move between modes, so you always know where you are. It's like leaving breadcrumbs as you explore.
Okay, breadcrumbs. That's a helpful way to think about it. So can you give me a few examples of these basic configuration commands just to get a taste of what it's like to actually configure a switch?
Sure. Some of the most common ones you'll use are hostname, password, and interface. Hostname is for, changing the name of the switch. Password is for, setting passwords for different login methods. And interface is for, you guessed it, configuring those individual interfaces.
Okay, so if I'm in global configuration mode and I want to change the host name of the switch to, let's say, My Awesome Switch, what would the command look like?
Simple. It would be hostname My Awesome Switch. Easy as that.
Nice. What about setting a password for the console line? Where would I do that?
You'd first need to go into line configuration mode for the console line, using the command line console 0. Then you'd use the password command, followed by the password you want to set.
Okay, so line console 0 to get to the right place, then password followed by the secret code.
Got it.
Got it. And I'm guessing the interface command works similarly.
Exactly. You use the interface command followed by the interface name to get into interface configuration mode for that specific port. From there, you can configure all sorts of things like the IP address, the speed, the duplex, even the VLAN membership for that interface.
So it's all about finding the right mode, using the right command, and then the switch responds, making the changes we want. But where are all these settings actually stored? It's not like they're magically floating in the air, right?
That's a great question. All those configurations are stored in special files within the switch's memory. The two main ones are running config and startup config.
Running config and startup config. Okay, I'm intrigued. Tell me more about these files and what makes them different.
Well, the running config is the active configuration, the one that's currently in use. It's stored in RAM, which is volatile memory. So if the switch loses power or reboots, poof, those changes are gone.
So running config is like a temporary workspace. I make my changes, but they're not saved permanently unless I do something specific.
Exactly. And that's where startup config comes in. This file is stored in NVRAM, which is non-volatile memory, so it retains its contents even when the switch is powered off.
So the startup config is like the master copy, the one that gets loaded when the switch boots up.
Precisely. To make your configuration changes permanent, you need to save them from the running config to the startup config. There's a specific command for that, copy running config, startup config.
Copy running config, startup config. Got it. It's like hitting the save button in a document to make sure your work isn't lost. And what if I want to, erase the entire configuration? Start with a clean slate.
There's a command for that too. Erase startup config. But be careful with that one. It wipes everything clean.
Okay, I'll handle that one with care. All this talk about configuration files is great, but let's zoom out for a second. We've got our switch configured, but what's the big picture here? What's the fundamental purpose of an Ethernet LAN switch in the first place?
At its heart, a LAN switch is like a traffic director, intelligently directing Ethernet frames between devices in a local area network. It's the hub that connects everything together.
So instead of every device shouting its messages to everyone else, the switch makes sure that the data gets to the right destination. How does it do that? How does it know where to send those messages?
It uses a MAC address table. Remember those MAC addresses, those unique hardware identifiers for every device?
Right. Every network card has its own MAC address, like a digital fingerprint.
Exactly. And the switch learns those MAC addresses by looking at the incoming frames. It associates each MAC address with the port where that frame arrived.
So the switch is constantly learning and updating its internal map of which MAC address is connected to which port. It's like a little detective figuring out who's who on the network.
That's a great way to put it. It's a self-learning device, constantly adapting to changes in the network.
That's pretty cool. So the next time a frame arrives with a specific MC address, the switch knows exactly where to send it. But what happens if the switch doesn't recognize the MC address? What if it's a new device or a device that's moved to a different port?
In that case, the switch has to flood the frame out of all its ports except the one it came in on. It's like sending out a general announcement. Hey, is this MC address out there?
And if the device with that MC address is connected, it'll respond, and the switch will learn its new location.
Exactly. The switch is always trying to learn new MC addresses and minimize flooding to keep things running smoothly.
Okay, that makes sense. Now, I remember something about switches and loops. Can you refresh my memory on what those are and why they're a problem?
Sure. Loops happen when you have redundant links between switches, to provide backup paths in case one link fails. But these redundant links can create a circular path in the network.
So a frame could get trapped in this circle, endlessly going round and round.
Exactly. It's like a data packet going through a revolving door, never reaching its destination.
Sounds like a recipe for network gridlock. How do we prevent those loops from wreaking havoc on our network?
That's where the spanning tree protocol comes in, or STP for short. It's a protocol that runs on switches, and it's designed to detect and block those redundant links that would create loops.
So STP is like a safety net for our network.
Right.
It makes sure those data packets don't get lost in the circular maze. Okay, we've covered a lot of ground here. We've talked about accessing the switch, navigating the CLI, even those all-important configuration files. But how do we know if everything's working correctly? How do we see what's going on inside the switch?
That's where those handy show commands come in. They're like our network detective tools, allowing us to peek into the switch and see what's happening.
Show commands. Okay, I'm ready to put on my detective hat. What are some of these commands and what secrets can they reveal?
One of the most useful ones is show MAC address table dynamic. This shows you the dynamically learned M ANDRE address table we were just talking about. You can see all the ME addresses the switch has learned, which ports they're associated with, and even the VLAN information for each entry.
So I can actually see the switch's internal map of the network. That's cool.
Exactly. It's a great way to verify that the switch is learning AMC addresses correctly. And it can help you troubleshoot connectivity problems, like if a device can't talk to another device, you can use this command to check if the switch even knows where that device is.
Very handy. What about checking the status of the interfaces themselves? To make sure they're up and running.
For that, you'd use the show interfaces status command. This gives you a quick overview of all the interfaces on the switch, their status, VLAN assignment, speed, duplex settings, and more. It's a great way to get a snapshot of what's going on with your ports.
So I can see which ports are connected, which ones are in use, which VLANs they belong to. What are the key things to look for in the output of this command? What should I be paying attention to?
Definitely keep an eye on the status and VLAN columns. The status column tells you whether the interface is up or down, and the VLAN column shows you which VLAN the interface belongs to.
Right. VLANs are like those virtual fences separating different groups of devices. Okay, so show interfaces status gives us a quick health check of our ports. Now let's talk about configuring those interfaces. We touched on speed and duplex settings earlier. Why are they so crucial for performance?
Well, speed and duplex settings basically control how fast and how efficiently the devices can communicate.
It's like making sure both sides of a conversation are speaking at the same pace. If one person is talking really fast and the other person is talking really slowly, it's going to be a mess.
That's a great analogy. Speed is, well, the speed of the connection. 10 millipees, 100 millipees, 1 Gbps. And duplex refers to whether the devices can send and receive data simultaneously, which is full duplex, or whether they have to take turns, which is half duplex.
So full duplex is like a phone call, and half duplex is like a walkie-talkie.
Exactly. And like a phone call, full duplex is way more efficient because there's no waiting around for the other side to finish talking.
So how do we make sure the switch and the connected device are using the same speed and duplex settings? Do we have to manually configure them on both sides?
Thankfully, most devices support auto-negotiation. It's a feature that allows devices to automatically figure out the best speed and duplex settings they both support. They exchange these special messages called fast link pulses to negotiate the best settings.
So auto-negotiation is like the diplomatic solution. The devices work it out between themselves.
Exactly. And most of the time, it works flawlessly. But there are times when you might need to manually configure these settings.
Like when?
Yeah.
When would I ever want to turn off auto-negotiation and go manual?
Sometimes you have to, especially if you're dealing with older devices that don't support auto-negotiation. Or if you're having some weird compatibility issues. In those cases, you'll need to manually set the speed and duplex on both the switch interface and the device to make sure they match.
Okay, so sometimes we have to be the network diplomats ourselves and manually set things up. If we do have to go manual, what are the commands for setting the speed and duplex?
You'll use the speed and duplex commands in interface configuration mode.
Yeah.
It's pretty straightforward. You just specify the speed and the duplex mode you want.
Easy enough. But I imagine there are some potential pitfalls when manually configuring these settings. What should I watch out for?
The most important thing is to make sure that both ends of the link have the exact same settings. If one side is configured for full duplex and the other side is configured for half duplex, you're going to have problems.
Ugh. Ah, the dreaded duplex mismatch. I've heard horror stories about those. What exactly happens when there's a duplex mismatch?
It's like two people trying to talk at the same time, constantly interrupting each other. The switch, thinking it's in full duplex mode, will send data whenever it wants, but the device, stuck in half duplex mode, will be waiting for a pause before it can send its data.
So they're talking over each other, causing collisions and lost data? Sounds messy.
It is, and the tricky thing about duplex mismatches is that the link might appear to be working, but you'll see slow speeds, dropped packets, all sorts of weirdness.
A real headache to troubleshoot.
Yeah.
How can I check the speed and duplex settings of an interface to make sure everything's configured correctly?
The show interfaces command is your friend here too. It shows you all sorts of details about an interface, including its speed and duplex settings. You can use this command to make sure both sides of the link are configured the same way.
Okay, so show interfaces is like our network X-ray vision, letting us see what's going on under the hood. And speaking of X-ray vision, let's talk about troubleshooting those inevitable interface problems. What are some of the common issues we might encounter, and how can we use the CLI to figure out what's wrong?
Well, one of the first things to check is the interface status. Remember those status codes we talked about earlier? Status and protocol. Those codes can give you a lot of information about the health of the interface.
Right. Status refers to the physical layer, like whether the cable's plugged in and the interface is sensing a signal. And protocol refers to the layer 2 operational state, like whether the interface can actually send and receive Ethernet frames.
Exactly. And those status codes can give you clues about what might be wrong. For example, if the status is not connect, it usually means there's a cabling problem, maybe a loose or damaged cable.
Okay, so if I see not connect, I know to check the physical connection. What about other status codes? What are some other common ones?
Connected usually means there's a physical connection, but the link might not be fully operational at layer 2. This could be due to a speed or duplex mismatch, a VLAN configuration issue, even a problem with the connected device.
So different status codes point us in different directions for troubleshooting. Okay, that's helpful. What about those duplex mismatches we were talking about earlier? How do they usually show up in the interface status?
A duplex mismatch can be tricky because the interface might actually show as connected even though it's not working properly.
So it's one of those silent but deadly problems. How can we be sure if a duplex mismatch is the culprit? What should we be looking for?
The show interfaces command can help here too. It gives you these counters that track different types of errors. By looking at these counters, you can often pinpoint the source of the problem.
Counters like the switch is keeping track of how many errors are happening.
Exactly. One of the most telling counters is late collisions. Late collisions happen when a collision occurs after the first 64 bytes of a frame have been transmitted. This is a classic sign of a duplex mismatch.
Okay, so late collisions are a red flag for duplex issues. What are some other counters we should be aware of? What else should we be looking for when we're troubleshooting interface problems?
Another important one is runts. Runts are frames that are too small, usually less than 64 bytes. They can be caused by, all sorts of things. Cabling problems, faulty network cards. It's like the data got chopped up during transmission.
So runts are like those tiny, incomplete messages that didn't quite make it through. What about the opposite? Are there like giants, frames that are too big?
Yep, giants are frames that exceed the maximum Ethernet frame size, and those can cause problems too.
Giants are like those oversized packages that get stuck in the mail chute. Okay, so we've got late collisions for duplex mismatches, runts for small frames, giants for big frames. Are there any other error counters we should know about?
Yes, CRC errors are another important one. A CRC error means that the data in the frame got corrupted during transmission. Maybe because of noise on the line or something like that.
CRC errors. Okay, I'll keep an eye out for those. So we've got our status codes, our error counters. We're starting to build a pretty good toolkit for troubleshooting these interface issues. All right, network ninjas. Let's get back into the world of Ethernet LANs. We've covered a lot of ground already, but there's still so much more to explore.
It's like peeling back the layers of an onion. The deeper we go, the more we discover.
Exactly. And today, we're going even deeper into those fascinating switch interfaces. We've talked about speed and duplex settings, auto-negotiation, troubleshooting. But now let's get into some of those really powerful configuration techniques.
Oh yeah, we've got some cool tricks up our sleeves. Like let's say you're dealing with a large network, a whole bunch of switches, tons of interfaces. It can get pretty tedious configuring each interface one by one, right?
Yeah, I can imagine. Typing in the same commands over and over again. Not very efficient.
Exactly. So what if I told you there's a command that lets you configure multiple interfaces simultaneously? Like with a single command.
Now you're talking my language. Tell me more about this magical command.
It's called the interface range command. It's like a superpower for network admins.
Interface range. Okay, I'm intrigued. How does it work?
It's pretty simple, actually. Let's say you have 24 interfaces that all need the same configuration. Instead of going into each interface one at a time, you can use the interface range command to target all 24 at once.
So it's like creating a group configuration that gets applied to multiple interfaces.
Precisely. It's a huge time saver, especially when you're dealing with large networks.
Okay, I'm sold. Can you give me an example of how I might use this command?
Sure. Let's say you need to configure gigabyte Ethernet interfaces 01 through 024. Maybe you want to assign them all to the same VLAN.
Okay, VLAN 10, let's say. How would I do that using the interface range command?
Easy peasy. You type in interface range gigabyte Ethernet 0124. That puts you into a special interface range mode.
Interface range mode. Got it. And then,
Then you'd use the command switch port access VLAN 10, boom. All 24 interfaces are now assigned to VLAN 10.
wow, that's amazing. A single command to configure a whole bunch of interfaces. That's power. Any other cool configuration tricks you can share?
Sure. Here's one that might seem simple, but it can make a big difference in terms of organization and documentation. The description command.
Description, you mean like adding labels to the interfaces?
Exactly. Like connection to server room or link to security cameras. Just a brief description that helps you identify what that interface is used for.
Okay, that makes sense. It's like adding comments to your code to make it more readable. How do I add these descriptions using the CLI?
Super easy. You go into interface configuration mode for the interface you want to describe, and then you just type in description followed by the text.
So if I want to describe Gigabyte Ethernet E01 as the link to main server, I'd type in description link to main server.
You got it. It might seem like a small thing, but trust me, when you're troubleshooting a network problem, or if you're handing off the network to someone else, those descriptions can be lifesavers.
Makes sense. I'm always a fan of good documentation. It's like leaving a trail of breadcrumbs for yourself or for the next person who has to work on the network.
Exactly. Okay, now let's revisit those shutdown and no shutdown commands we talked about earlier.
Right. Those are for administratively enabling and disabling interfaces, right? Kind of like a virtual on-off switch.
Precisely. So let's say you need to do some maintenance on a server that's connected to your switch.
Okay, I'm following.
You could physically unplug the cable, but that's kind of a hassle, right?
Yeah, especially if the server is in a remote location.
Exactly. So instead of unplugging the cable, you can just use the shutdown command on the corresponding interface. That effectively disables the port, so no traffic can flow through it.
So it's like a virtual disconnect.
Mm.
And once the maintenance is done, I can use the no shutdown command to bring it back online.
You got it. It's a simple and convenient way to control the state of an interface.
And I remember you mentioned that those status codes we talked about earlier will reflect those changes, right?
Absolutely. A shutdown interface will show as administratively down in the show interface status output.
Okay, good to know. Now let's dive back into those status codes. They're like those cryptic clues in a detective novel, right?
They are. And they can be really helpful for troubleshooting. Remember, we're looking at both the status and the protocol columns.
Right. Status for the physical state and protocol for the layer 2 operational state.
Exactly. And we want to see connected in both columns for a healthy interface.
So if I see connected in both columns, I can breathe a sigh of relief knowing that the interface is up and running.
Well, not so fast. Even if the interface shows as connected, it might not be working properly. That's where those error counters come in.
Ah, right. Those counters are like our network forensic tools, giving us those telltale signs of trouble.
Exactly. So let's say you see a lot of late collisions.
That's a sign of a duplex mismatch, right? The devices aren't agreeing on when to transmit data, so they keep crashing into each other.
You got it. And then there are those runts, those undersized frames that can indicate all sorts of problems, like maybe a bad cable or a faulty network card.
Runts, giants, those are always fun to troubleshoot.
Mm-hmm.
And what about CRC errors? Those are usually a sign of a physical layer problem, right? Like a bad cable or interference on the line.
Exactly. CRC errors mean that the data got corrupted during transmission. So yeah, definitely a physical layer issue to investigate.
Okay, so we've got our status codes, our error counters. We're building quite the arsenal of troubleshooting techniques. Now let's talk about something that can save us a lot of headaches when it comes to cabling. Auto MDIX.
Ah, yes. Auto MDIX, one of my favorite features. It's like magic.
Magic? Tell me more.
Remember back in the day when you had to use different types of cables for different connections? Like a straight-through cable for connecting a switch to a router and a crossover cable for connecting a switch to a switch?
Oh, I vaguely remember those days. It was so confusing. I always had to double-check which cable to use.
Well, with Auto MDIX, you don't have to worry about that anymore. The switch automatically detects the type of device connected to the other end of the link and configures the interface accordingly.
So I can just use a straight-through cable for everything. No more crossover cables.
Exactly. It simplifies things so much.
That's amazing. I love it when technology just works. I'm guessing most modern switches have Auto MDIX enabled by default?
Yes, pretty much. But it's always good to double check, especially if you're working with older equipment. Okay, now let's talk about a really important concept in Ethernet switching, VLANs.
VLANs, Virtual Local Area Networks. I've heard the term, but can you give me a refresher on what they are and why they're so important?
Sure. VLANs allow you to segment your network logically, create separate broadcast domains even if the devices are physically connected to the same switch.
So it's like creating virtual walls within the network.
Exactly. It's all about controlling the flow of traffic and enhancing security.
Okay, that's starting to make sense. Can you give me a real-world example of how I might use VLANs?
Sure. Imagine a small office with different departments. You could create separate VLANs for each department. One for accounting, one for marketing, one for sales. That way, the traffic from each department is isolated from the others.
So it's like having separate rooms for each department, even though they're all in the same building.
Exactly. It helps improve security because devices in one VLAN can't see the traffic from devices in another VLAN. And it can help with performance, too, because broadcasts are contained within their VLANs.
Okay, I'm starting to see the benefits, so how do I actually create and configure these VLANs on a Cisco switch?
First, you create the VLANs themselves. You do this in global configuration mode using the VLAN command followed by the VLAN number. So to create VLAN 10, you'd type VLAN 10.
VLAN 10, got it. What's next?
You can give the VLAN a name if you want using the name command, like name accounting for VLAN 10. And then you assign interfaces to the VLANs. You do that in interface configuration mode using the switchport access VLAN command followed by the VLAN number.
So to assign Gigabit Ethernet 01 to VLAN 10, I'd type in switchport access VLAN 10.
You got it. And that's it. Now, any device connected to that interface will be part of VLAN 10.
Nice. So we've created our VLANs, we've assigned interfaces to them. What happens if I connect a device to an interface that hasn't been assigned to a VLAN?
By default, all interfaces on a Cisco switch belong to VLAN 1. It's the default VLAN.
Okay, so VLAN 1 is like the main lobby of the building. Everyone starts there unless they're specifically assigned to a different room.
That's a good way to think about it. Now, what if you want to connect two switches together and allow VLAN traffic to flow between them? That's where trunking comes in.
Trunking? Okay, tell me more about this trunking business.
A trunk is a special type of link that carries traffic for multiple VLANs. You typically use trunks to connect switches to each other or to connect a switch to a router.
So it's like a multi-lane highway for VLAN traffic.
Exactly. And to configure a trunk on a Cisco switch, you use the switchport mode trunk command in interface configuration mode.
Switchport mode trunk. Got it. So that tells the switch that this interface should be treated as a trunk port. Are all VLANs allowed to cross a trunk by default?
Nope. Cisco switches use VLAN pruning to control which VLANs are allowed on a trunk. By default, only VLAN 1 is allowed.
Ah, VLAN 1, that default VLAN always sneaking in. How do I add or remove other VLANs from the allowed list on a trunk?
You use the switchport trunk allowed VLAN command. You can either add or remove VLANs from the list.
Okay, so I can customize which VLANs are allowed to use the trunk. Cool. Now let's talk about those special types of frames, broadcasts and multicasts. How do switches handle those?
Ah, yes. Broadcasts and multicasts. They have their own set of rules.
Right, broadcasts are like those network-wide announcements, right? They're sent to every device on the network. And multicasts are for a specific group of devices, like a video conference or a live stream.
You got it. So with broadcasts, the switch floods the frame out of all its ports except the one it came in on. But with VLANs, broadcasts are contained within their respective VLANs.
So VLANs help to keep those broadcasts from flooding the entire network. That's good for performance. What about multicasts? How do those work?
For multicasts, the switch uses a special multicast forwarding table. It tracks which devices belong to which multicast groups, and it forwards the multicast frames only to those devices.
So it's a more targeted approach than flooding.
Exactly. It helps to conserve bandwidth and improve efficiency. Multicast is a pretty complex topic, though. We could probably do a whole deep dive on just multicast alone.
Okay, we'll add that to our list for future episodes. For now, let's wrap up this part of our deep dive with a quick review of what we've covered.
Sounds good. We started with some powerful configuration techniques like the interface range and description commands.
Those commands can save you so much time and effort, especially when you're dealing with large networks.
And we talked about those all-important status codes and error counters. Remember, those are your troubleshooting best friends.
And who could forget Auto MDIX? No more cable confusion.
And then we delved into the world of VLANs, virtual fences for segmenting your network and enhancing security.
We've covered a lot of ground, but there's still more to come. Stay tuned for the final part of our deep dive, where we'll explore even more advanced techniques for configuring and troubleshooting those essential switch interfaces. All right, welcome back to What's Going On in the Internet, everyone. Ready for the final stretch of our Ethernet LAN deep dive?
Ready when you are.
We've been exploring the ins and outs of those essential network building blocks, But before we wrap up, let's do a quick recap of all the key concepts we've covered, just to make sure everything's nice and solidified in those brain cells.
A good review session never hurt anyone, especially if you're prepping for those CCNA exams.
Absolutely. So let's rewind those mental tapes and revisit the highlights of our Ethernet LAN adventure.
Sounds good to me. Where do we even begin? So much ground covered.
Right. Let's start with the beginning, that first encounter with the switch. Remember, we talked about accessing the switch, that command line portal to all the network magic.
Ah, yes. Console, Telnet, SSH, those were our trusty access methods, each with its own pros and cons.
Exactly. Console for those direct connections, Telnet for remote access, though not so secure, and SSH, our encryption hero, keeping those communications safe and sound.
Can't forget about security. That was a big one. Always change those default passwords. Otherwise, you're just asking for trouble.
Absolutely. Security first is like locking your front door. Okay, so once we got into the switch, we delved into the wonderful world of the Cisco iOS CLI, that command line interface where all the real action happens.
Ah, yes, the CLI. Land of cryptic commands and unlimited network power.
We navigated through those different modes, user EXEC, privileged EXEC, each granting different levels of access, like ascending through the ranks of network mastery.
And those context-sensitive commands were our trusty guides, leading us deeper into the configuration labyrinth, unlocking the secrets of interfaces, lines, VLANs, and so much more.
It was like a choose-your-own-adventure, but for network configuration.
I love that analogy. And of course, we couldn't forget those configuration files, those digital blueprints that store all our hard work, the running config capturing the current state, and the startup config loaded upon boot up.
Saving those changes from running config to startup config was like hitting that save button in a document.
Absolutely crucial. Those changes are fleeting unless they're saved in that non-volatile memory, safe and sound.
Then we embarked on a journey to understand the heart of Ethernet LANs, how those switches work their magic, directing traffic, keeping those connections humming. It's all about learning ULC addresses, building that internal map of the network, making sure those frames reach their intended destinations.
Like a network postal service, ensuring those data packets are delivered on time.
And when the switch encounters a new device, it floods those frames, spreading the word, seeking the unknown.
But too much flooding can lead to congestion, so the switch learns quickly, building its knowledge base to keep those broadcasts in check.
And to prevent those network loops, those circular traffic jams, we have the spanning tree protocol, our trusty traffic cop, ensuring a smooth flow of data.
STP, always there to save the day.
Next, we dove into the nitty-gritty of configuring those switch interfaces, focusing on those crucial speed and duplex settings, the parameters that dictate how fast and efficiently devices can communicate.
Remember those fast link pulses? Those negotiation signals that devices exchange, trying to find that perfect match in speed and duplex.
Yes, auto-negotiation, our network matchmaker, bringing those devices together in harmonious communication. But sometimes those negotiations fail, and we have to step in and manually configure those settings, especially when dealing with other devices that don't speak the same language.
And those duplex mismatches, those communication clashes, can cause all sorts of headaches, slowing things down, dropping packets, creating all sorts of network hiccups.
To diagnose those ailments, we turn to those trusty interface status codes, those cryptic clues that reveal the health of our connections.
Connected, not connect, air disabled. Each code whispers a story about the state of our physical and logical connections.
And then we have those error counters, our network forensics toolkit. Those late collisions, runts, giants, and CRC errors, revealing the telltale signs of trouble.
Those counters, they're like the smoke detectors of the network world, alerting us to those potential fires before they spread.
And speaking of handy tools, we can't forget those time-saving configuration commands like interface range, letting us configure multiple interfaces at once, like a network multi-tool, streamlining our workflow.
Efficiency is key in the world of network management.
And those descriptive labels we can add to our interfaces, those breadcrumbs of documentation, making it easier to navigate and understand those connections, especially in those large, complex networks.
A well-documented network is a happy network.
And then there was Auto MDIX, our cable-saving hero, eliminating those crossover cable conundrums, allowing us to use the same cable type for all our connections.
Auto MDIX is like the universal adapter of the networking world.
And finally, we explored the world of VLANs, those virtual fences that allow us to segment our network, enhancing security and controlling those broadcast storms.
VLANs, those logical partitions shaping the flow of traffic, keeping those different departments or groups separated and secure.
Phew! We've covered a lot of ground. From those first steps of accessing the switch to the advanced techniques of configuring interfaces, troubleshooting problems, and mastering those essential concepts like VLANs. But remember, this is just the beginning of your networking journey.
Exactly. There's always something new to learn, some new challenge to conquer.
So keep exploring, keep experimenting, and keep those networks humming. And remember, we're always here to help you along the way. You can find a ton of resources, articles, and even practice quizzes on our website.
And don't be afraid to reach out if you have any questions.
We're here to support you every step of the way. Thanks for joining us on What's Going On in the Internet.